Let's look at Chapter 3 on safety engineering. Safety engineering refers to projects, safety projects. Because we often talk about engineering projects, it discusses the safety solutions in IT projects which we need to implement, such as framework design, including the definition of standard plans. It is a safety solution. So this chapter is usually what our CEO, the security middle layer, and the security department mainly consider. As we mentioned in Chapter 1, a company needs to have a safety strategy or direction. And the solution we are going to implement is in this IT construction, including the solution of safety projects. These practices, including processes, need to be consistent with the strategic direction. This is easy to understand because the strategic direction, including the company's safety policy, has been set. How do I implement this policy? It must be promoted through practice and process. For example, the algorithms we talk about, including physical security protection, which is the protection of the computer room, all belong to the effective implementation of the company's safety policy. Let's take a closer look. This is the framework of the whole chapter. Let's look specifically at the first thing, which is the life cycle of project management. Because we need to embed safety into the entire project management process, we first need to understand what the life cycle of the project is. The popular one now, although there are some new models, is based on this framework, which is the V model. The V model is a very important underlying timeline-based framework in project management. Of course, there is also work content. What we need to focus on is the relationship between safety and the V model. First of all, why is it the V model? It's the left half, the left side of the V. We consider this part. As planning, that is, our daily plans are on the left side, and the bottom of the V is called execution, which is what we call coding. That is to write code. Whether it's a safety project or an IT project, we need to execute these processes through programming. The right side of the V model, we focus on testing, which is safety assessment. So it divides a project, the left half and the right half. What are the safety points they need to consider separately? He explained it with that model. First of all, from the concept of operation, what is the concept of operation? Generally, it refers to the reason for the project initiation, which must go through an approval and business justification process. This process can consider safety, but usually does not consider safety, because we first need to understand that this safety is a safety requirement, a non-functional item, a non-functional requirement. That is to say, it ensures the safe and effective implementation of the project. So safety requirements, generally speaking, are non-functional items. We do not consider them as key points. As a project, the first thing we need to consider is business requirements, how to satisfy the business, such as our mechanism reform or process optimization. We should consider these things first. If you need project management, there is a value enhancement in the business justification, which actually has two parts. One is the increase in profits for the enterprise. The other part may be to improve the company's reputation. In layman's terms, it's fame and fortune. Generally speaking, this is what the project pursues, unless it's a safety project. Otherwise, we start with planning, that is, at the operational stage. Usually we do not consider safety. Then it's about requirements and architecture. Do we need to consider safety when we collect requirements and define the scope? This part can consider safety because specific requirements come from stakeholders. Stakeholders create or provide input for requirements. Among the many requirements of stakeholders, safety requirements are also very important, such as laws and regulations, because of regulatory authorities or the country has corresponding requirements, including our data usage process. The owner may also have related requirements for data security. We can consider safety. Of course, as a safety requirement, it is still a non-functional requirement, so we should focus more on business requirements, including functional requirements, such as if we want to build a CRM system, how to create customers, how to realize the details of customers, and how to associate customers with orders, including our products. These are functional requirements that need to be considered. How to keep this data confidential, how to achieve backup as a safety requirement. It is not unimportant. It does not directly create this business value. So it is a non-functional requirement. Here I need to emphasize one point, which is this acceptance. The standard for this acceptance is actually in the planning stage. That is, we need to be clear when we collect requirements or when we design in detail. It's not that I need to consider the acceptance standard in the later testing stage. No, it's in the early stage. That is, when we are planning, even before a piece of code is written, we need to consider its acceptance standard. So we need to understand this. Once we have the requirements of stakeholders, then we enter the detailed design. What is detailed design? It's what we call modularization. Yes, I have to divide a whole product definition or a complex solution into several modules. Of course, safety as a module and also a major module needs to be considered in the detailed design stage. To sum up, we find that we need to consider safety requirements. That is, safety requirements, generally speaking, are not considered in the operation stage or project initiation stage, but at the latest, we need to consider safety in the detailed design stage. Otherwise, this safety cannot be embedded. For example, we have started writing code in the execution stage. If you say I embed safety functions into this code, it's actually difficult, like 3A, such as authentication, authorization, billing. These functions, they must be as a whole architecture or a structured design should be put in the early planning. I have written code, you put 3A, authentication, billing, authentication, authorization, including audit functions. You embed it again, it's very difficult. And now, development, also specifically mentioned, that is TDD. Called test-driven development, for example, for some APPs or for some software with a high security level, its product definition may actually be through testing requirements. That is, what I test, what results I need to test. So it meets these testing standards and requirements to define the software requirement. So this current development, on the contrary, takes testing more seriously and may put it in the early stage of the previous stage. In the execution stage, of course, we also mentioned that more is writing code, but this code writing process also needs testing. Yes, this test we will expand in detail in the future, called unit testing, because it's for modules, right? I write a module of code, then I need to do corresponding tests for that module of code, which is unit testing. Unit testing is generally code auditing. Why is it code auditing? Of course, it's for the original code, because at this time there is no mature software product. Even the module is in the process of development. It's all code. So he focuses more on code auditing. Of course, testing is not the most important part during the execution process. Programming is definitely the main focus. But now, there is a type of development such as baseline development or competitive development, which requires zero defects during the development process. How to achieve zero defects? Now there is a popular solution, which is pair programming. In pair programming, you can understand it as two people developing a piece of code or a set of codes at the same time. Some people often ask if this will reduce efficiency. I thought so at first, but if you look at it from a macro perspective, when two people develop a piece of code at the same time, one person writes and the other checks. Or if two people are developing the same function and the codes are different, it may trigger an alarm. Then we will check to see who wrote better or if there are conflicts or ambiguities. So it's like testing while developing and get it done together. So pair programming seems to sacrifice individual efficiency on the surface, but actually from a macro perspective, it improves the overall success rate of software development and reduces the cost. Then in the execution phase, we do unit testing, which is code auditing, and then gradually generate one module after another. All the modules involved in our software have been completed. Then we have integrated development or integrated testing. If you are not familiar with integrated testing in domestic projects, it's called joint debugging. It's about different departments or modules working together for debugging. The main purpose is clear, which is whether the overall architecture of my software, including the process, can run. It pays more attention to the input-output relationship. That is, the output of this module comes from a deep processing of the input of the previous module. If the input provided by my previous module is problematic or incomplete, then my output will definitely be missing. So through the flow relationship between modules and the input-output relationship, we conduct testing, which is more about structural and systematic testing. If this integrated testing is fine, it means that the software meets the functional requirements, or the software as a whole can run, and then we do system testing. When it comes to system testing, what we test more here is compatibility. There is some subjectivity in what I say because testing has many aspects, but this is easier to remember, that is, it mainly tests compatibility. There are many types of compatibility, including hardware and software compatibility. For example, our compatibility with the server, including network compatibility and environmental compatibility, because from a business function perspective, it cannot replace all system functions. So it is just one of many software or business lines. Can I effectively link up with other software and other businesses? Can this data be shared and exchanged? There is also compatibility with the environment. What else? There is also compatibility with customers. For example, some companies develop software that can only run on IE browsers, which is a poor customer experience because we can't control what kind of method or tool customers are used to accessing. So during this compatibility testing, I might have to consider whether it can run effectively on Google's browser, Firefox, and Opera. So there are many compatibility tests. And finally, the most important compatibility is with the customer's environment. Then I also need customer acceptance. Finally, in the customer's production environment, if the customer thinks it's okay, then our product has no problem, including the security he approves. Actually, this approval represents acceptance of the residual risk or remaining risk of this software. Your software may still have some bugs and problems because software always has some unknowns or vulnerabilities that cannot be detected, but I think I can accept it. Then here there will be a customer acceptance process, which is the acceptance report, the customer signs, and then enters the operation and maintenance stage. During operation and maintenance, as we mentioned earlier, as long as it is software, it will inevitably have vulnerabilities. Some vulnerabilities are just what we detected, and some vulnerabilities cannot be detected, but it does not mean they do not exist. So during the operation and maintenance stage, we still need to carry out maintenance and testing. There are mainly two types here. One is what we call vulnerability scanning. We use the vulnerability database to continuously scan our software to see if it has bugs or problems. Another one is penetration testing. We may do this kind of red-blue confrontation test with. We use this red-blue attacker and defender method to simulate testing. Of course, the testing here is mainly black box testing, which is mainly testing from the perspective of a hacker just to see if there is a problem with your program's response. So when we talk about this, we will find that the left half is about considering security during the early planning stage. The right half is about considering security during testing and acceptance. At the bottom, we also need to consider security during programming. The ultimate goal is that if I find a problem through testing, then I have defined a new security requirement which promotes the software to a higher level or to upgrade to a safer level. So the V model actually complies with the security guarantee strategy proposed by our country, which is synchronous planning. That is, security is planned synchronously, then it is synchronous construction. The so-called synchronous construction is synchronous implementation. That is, I have to consider security during the execution process. Another one is synchronous operation and maintenance or synchronous use. That is, our security. We also need to consider security during the later use process. This security needs to be guaranteed during the use process. This principle of three synchronizations, of course, there may be some differences in the wording, but the logic is the same. Actually, it's just that everyone's understanding of security, the translation of its explanation may be different. But the logical relationship is that I consider security during planning, I consider security during execution, and I also need to consider security during operation and maintenance. In this way, security can be ensured throughout the product lifecycle. We also mentioned earlier that at the latest, our security needs to be considered during architectural design. If we do not consider security in architectural design, it will be difficult to integrate security later. You can take a look at this picture. This picture is actually the V model written in modules, this advancement process, finally confirmed, and then we go online. After going online, we still need to do vulnerability scanning and penetration testing. From the timeline, from the perspective of management tools or modules, it is clear that risk management is very important for the security of the entire development process. Because we know that risk management is actually security requirements. Where does security come from? Isn't it from problems? So risk management is a very important tool and module in the entire development process. Another one is configuration management. In this place, there are actually two tools. One is change. That is our change process. Corresponding changes can have, but it needs high level approval. Then there are some changes. Another one is the version. A very important part in the configuration is the update and maintenance of the version. Good maintenance, configuration system or version maintenance habits can greatly improve the success rate of a company or a developer, a supplier's project. Then there are other requirements for compliance, including some interfaces, compatibility, management, all need to be considered, but the most important one is risk. One is configuration. These two are really important in the development process. How to ensure in the development process? Here involves three elements of security assurance. These three elements are personnel technology and our so-called operation and maintenance control points. Let me emphasize again, personnel technology and operation and maintenance. That is operation. Three aspects. Personnel, in fact, is management. The process, including the improvement of personnel's ability, including the relationship of authorized groups. Then technology is one module after another. Then operation and maintenance is our so-called patching, later vulnerability scanning, penetration testing. These things, among these three elements, people are the most important. The management of personnel safety is the most important. Some students say that safety should be more important in technology. Of course, this sentence itself is not wrong, but you will find that many times technical means may not be able to achieve good results. It is people's cognition, including habits, including consciousness is very important. So, human machine management, our book also mentions timely management. So, personnel management is also a very important part of safety. Then we have a basic understanding of this safety project management. How to judge whether it is safe? Here are many evaluation standards and criteria. The so-called evaluation standards are actually to verify our ability to meet the safety standards of a project. So he is actually a best practice, we say. That is to say, there was no standard at the beginning. Then these leading companies, they have walked a lot of roads. Then the roads they have walked or they think is a cost-effective practice, then it becomes a standard. So how does this standard come? How does it come? For example, the book mentioned the following units. You can refer to it. You won't be tested in the exam. The specific standards or models of each country, such as NIST, the American Institute of Science and Technology, they propose 33 IT principles. In the whole development process, it is divided into 6 categories, including the foundation of safety, including risk-based management, including ease of use, reduce vulnerability, can improve more redundancy availability, including the underlying network design. It has corresponding modules. This is a standard. There are a series of standards such as CIS is the internet security. This center it proposed also has corresponding standards, including ISO 27000 also has corresponding standards. Looking at these standards, in fact, it is all to achieve a component, or let us have our own view of safety or a reference model. Different components have their own relatively complete view and opinion, just like each discipline or like each school. Like psychology has many schools, different schools. They all have their own views and opinions. Then how to evaluate a company, its safety can reach what level? Here is a thing called SSE-CMM, called security engineering, called this security system engineering. What maturity model? If you have studied maturity, you are relatively familiar with CMM. There is also a CMMI we will talk about in the future. is the software development maturity model. Then the maturity model of security engineering is very similar to this CMMI. It is also divided into 5 levels. Just listen and understand. This is not the focus. The first level is called the initial level. That is, I can at least complete this project, can ensure that the final product is at least deliverable. That is, tell the truth. Then the second level is called repeatable level. That is, after I have done several projects, I have organizational assets, some templates, then I can learn and repeat. This is the second stage. Then to the third stage, it is called it is predictable or can be defined. It has a foresight. That is, before the project starts, I know roughly what level I can achieve, whether my project is successful. I have a planned process. This is the third level, called definable. The fourth level is called manageable, or you can understand as measurable. Then I have a plan, have a process. Further refined, I have control of the plan and process, or test standards. That is, I execute to which step. I use KPI use value. I can test whether it meets my requirements for you. Then to manageable, it has test and evaluation standards. Then in this way, it is convenient for us because if you can define it, how to control this process, or at a certain point in time, I have to reach a standard. Then the fourth stage is manageable. The highest stage of maturity, we call it perfectible or optimizable. Then to the stage of optimizable, you can understand as I can on the original process, including the original standard measurement. On this data, I keep adjusting and optimizing. In this way, the probability of our project's future success will be higher and higher. So this is SSE-CMM. That is, we say security engineering, the evaluation method of the maturity of security system engineering. There are also some evaluation institutions in China. If you want to check, you can check on the internet. It is also referring to this SSE-CMM evaluation method. There are also some evaluation institutions in China. If you want to check, you can check on the internet. It is also referring to this SSE-CMM evaluation method. There are also some evaluation institutions in China. If you want to check, you can. This model has about 22 evaluation domains in total. That is, we say the content of the evaluation work. Then each evaluation domain has 5 levels. That is, we just said these 5 levels. Then after I evaluate the maturity of each evaluation domain, I will get a pricing result in combination. This is what we call SSE-CM.